Welcome to Huberman Lab Essentials, where we revisit past episodes for the most potent and actionable science-based tools for mental health, physical health, and performance. I'm Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. This podcast is separate from my teaching and research roles at Stanford. It is, however, part of my desire and effort to bring zero cost to consumer information about science and science-related tools to the general public. Today, we're going to talk about and focus on skill learning. We are going to focus on how to learn skills more quickly, in particular motor skills. So if you're interested in how to perform better, whether or not it's dance or yoga or even something that's just very repetitive like running or swimming, this podcast episode is for you. We're going to go deep into the science of skill learning, and we are going to talk about very specific protocols that the science points to and has verified allow you to learn more quickly, to embed that learning so that you remember it, and to be able to build up skills more quickly than you would otherwise. Let's talk about the acquisition of new skills. These could be skills such as a golf swing or a tennis swing, or you're shooting free throws, or you're learning to dance, or you're learning an instrument. I'm mainly going to focus on athletic performance. There are basically two types of skills: open loop and closed loop. Open loop skills are skills where you perform some sort of motor action and then you wait and you get immediate feedback as to whether or not it was done correctly or not. A good example would be throwing darts at a dartboard. So if you throw the dart, you get feedback about whether or not you hit the bullseye. That's open loop. Closed loop would be something that's more continuous. So let's say you're a runner and you're starting to do some speed work and some sprints, and you're running and you can kind of feel whether or not you're running correctly, or maybe you even have a coach and they're correcting your stride. That's closed loop, because as you go, you can adjust your behavior and you can adjust the distance of your steps, or you can adjust your speed, or you can adjust your posture. You're getting feedback on a moment-to-moment basis. There are essentially three components of any skill that involves motor movement, and those are sensory perception, actually perceiving what you are doing and what's happening around you. Then there are the actual movements. And then there's something called proprioception. And proprioception is often discussed as kind of a sixth sense of knowing where your limbs are in relation to your body. Now, skill learning has a lot of other dimensions too, but those are the main ones that we're going to focus on. So anytime we learn something, we have to decide, is it open loop or closed loop? The second question should be, what should I focus my attention on? Auditory attention, visual attention, or proprioception. Should I focus on where my limbs are relative to my body, or should I focus on the outcome? Okay, this is a critical distinction. You can decide to learn how to do a golf swing or dance tango and decide that you are going to focus on the movements of your partner or the positions of your feet, or maybe you're going to sense the position and posture of your body, which is more proprioceptive. Okay, so you have to allocate your attention, and I'm going to tell you how to allocate your attention best in order to learn faster. So these are the sorts of decisions that you have to make. So we can really simplify things now. I've given you a lot of information, but we can simplify it. Basically, open loop or closed loop, that's one question. And what am I going to focus on? And then your neurology will take care of the rest. So now I want to talk about realistic expectations. Somewhere in Hollywood, presumably, it got embedded in somebody's mind that instant skill acquisition was possible, that you could take a particular pill and you would suddenly have a skill. And I love movies, but it simply doesn't exist. Then the self-help literature created another rule called the 10,000 hours rule. And frankly, that doesn't really match the literature, at least the scientific literature, either. I like it because it implies that learning takes time, but the 10,000 hours rule overlooks something crucial, which is that it's not about hours, it's about repetitions. Now, of course, there's a relationship between time and repetitions, but there are some beautiful experiments that point to the fact that by simple adjustment of what you are focused on as you attempt to learn a new skill, you can adjust the number of repetitions that you do, you adjust your motivation for learning, and you can vastly accelerate learning. Some of you may recognize this by its internet name, which is not a scientific term, which is the Super Mario effect. The Super Mario effect relates to the game Super Mario Brothers, but you'll see why at the end. But basically what they did was they had 50,000 subjects, which is an enormous number of subjects, learn a program, essentially taking words from a computer program or the commands for a computer program that were kind of clustered in a column on the right. And those commands are essentially translate to things like, go forward, and then if it's a right-hand turn in the maze, then go right and continue until you hit a choice point, etc. So it's a bunch of instructions, but the job of the subjects in these experiments were to organize those instructions in a particular way that would allow a little cursor to move through the maze successfully. It takes some skill. You have to know what commands to give in what particular order, and they made that very easy. You could just assemble them in a list over onto the right. Now, there were two groups. And one half of the subjects, if they got it wrong, meaning they entered a command and the cursor would move and it was the wrong command for this little cursor to move through the maze, they saw a signal jump up on their screen that said, "That did not work, please try again." The subjects would reorganize the instructions and then the little cursor would continue. And if they got it wrong again, it would say, "That did not work, please try again." Okay? The other half of the subjects, if they got something wrong, were told, "You just lost 5 points. Please continue." So that's the only difference in the feedback that they got. Now, I have to confess, I would have predicted, based on my knowledge of dopamine circuitry and reward contingency, people will work much harder to prevent losing something than they will to gain something. And it turns out that that's not at all what happened. If they looked at the success rate of the subjects, what they found was that the subjects that were told, "That did not work, please try again," had a 68% success rate. 68% of them went on